Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. At this point, you know how to differentiate a lot of different expressions, as long as they're written in a form of sum and differences. This means we need to rely on some algebraic techniques to ensure that we have our expressions in this form. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. We're going to start with a couple of practice questions. We want to differentiate our f of x and our g of x. But notice how for f of x, we have a multiplication here. And for g of x, we have a division. And we haven't learned how to differentiate with these operators yet. So this means we need to go ahead and do some algebraic manipulations first. So first, for f of x, because we have a multiplication, we're going to go ahead and distribute that. So if we distribute our x squared, we're going to get f of x is equal to x to the power of 5 minus 4 times x to the power of 2. And now we have terms that are powers of x, and they're joined together by sum and differences. This means we're now ready to differentiate. We have f prime of x is equal to, now using our power rule, the derivative of x to the power of 5 is going to be 5 times x to the power of 4. So if you recall, what we do is we take the power, we bring it down to the front, and then the resulting power is going to be 1 less. And then the next term, this is going to be minus 4 times, and the derivative of x squared is 2x to the power of 1. So this means f prime of x is equal to 5 times x to the power of 4 minus 8x. Now similarly for g of x, we're going to go ahead and do our division first. So this means g of x is equal to, and since our denominator is just x, we can go ahead and divide each term individually. So we get g of x is equal to x plus 3. To differentiate g of x, that would be g prime of x, the derivative of x. So x is just x to the power of 1, which means using the power rule, this is going to be 1 times, and then we would have x to the power of 0. And we know that the derivative of a constant is 0. So therefore, g prime of x is equal to 1. Now for our next example, we're asked to find the equation of the tangent line to our function f of x at x is equal to 2. Now that we started to learn all these tricks for differentiating, it is important that we don't lose sight of what f prime of x actually gives us. We should always remember that it represents the slope of the tangent line to a curve at a specific point. So if this question is asking for the equation of the tangent line to this function at x is equal to 2, the first thing we need to find is what is the slope of the tangent line. And f prime of x is going to give us that. So f prime of x is going to be equal to 3 times x to the power of 2 minus 2. Now this gives us the slope of the tangent line at any x value. But the x value that we're interested in here is x is equal to 2. This means in order to find the slope of the tangent line at x is equal to 2, all we need to do is substitute 2 into our x for f prime of x. So f prime of 2 is equal to 3 times 2 squared minus 2. And this is equal to 10. So again, remember that this is the slope. Now, the other thing that we need to find in order to get the equation of the tangent line is a point. So right now, we know that the x value is equal to 2, but we need to find the y value for us to get the coordinates of the point. And to do that, we just need to substitute 2 into our f of x. So f of 2 is equal to 2 to the power of 3 minus 2 times 2. And this is equal to 4, which means the point is 2, 4. So this here is our point. And now we have all the information that we need to find the equation of the tangent line. We have our slope and we have our point. So we can use our slope-point form to get the equation of the tangent line. The slope-point form is y minus y1 is equal to m times x minus x1, where x1, y1 is the coordinate of the point. So substituting in what we know, we have y minus 4 is equal to 10 times x minus 2. And this is going to be the equation of the tangent line to our function f of x at x is equal to 2. Next, we're going to introduce a new term called the normal line. Now, the normal line is defined as the line that is perpendicular to the tangent line at the point of tangency. So let's go ahead and quickly draw a diagram so that you can see what it means. So let's say we have our function f, and it looks something like this. So this is our function f of x. Now let's say at this particular point, our tangent line is going to look something like this. So this is the tangent line at this particular x value. Now the normal line to this point is going to be the line that is perpendicular to this tangent line at this point, which means the normal line is going to be this line right over here. So here we have a 90-degree angle. So this is our normal line. And the relationship between two perpendicular lines is that their slopes are negative reciprocals of each other. So if our tangent line has a slope that is equal to m, then our normal line is going to have a slope that is equal to negative 1 over m. So using our previous example, we want to find the equation of the normal line to our function f of x at x is equal to 2. Well, earlier we found that the point here is 2, 4. And then for our tangent line, we had a slope that was 10. This means the slope of our normal line is going to be negative 1 over 10. So therefore, the equation of the normal line here is y minus 4 is equal to negative 1 over 10 times x minus 2. And now let's do a quick recap of what we covered in this video. We saw that if our function included products and quotients of terms, we want to write it before differentiating. So that means distributing the products and splitting up the fraction into sums and differences. And that's only for now, because in a future video, we'll learn how to deal with them. We saw that if we had radicals or powers of x in the denominator, we want to rewrite them as fractional and negative exponents instead. We reiterated the fact that f prime of x gives the slope of the tangent line at any x value. And it's important that you always keep that in mind. We learned a new term, which is the normal line. And normal lines are perpendicular to tangent lines, which means their slopes are negative reciprocals of each other. And now it is your turn to give this a try. Can you find the equation of the tangent line and the normal line to f of x at x is equal to 2? Make sure to leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.